about a shark-ass man.
Okay, hi there. Today I'm going to be looking at Chapter 4-8 for Algebra 2 of complex numbers and radicals. So I'm going to start off by showing you how to reduce a radical. You know that this is what's called a, it's a non-perfect square, and I know you can get a decimal if you punch it in your calculator, but in math we like to reduce the radicals because it's an exact answer. Whatever decimal you're getting in your calculator is a rounded off answer, so it's not exact. So the way we do this, now we need to probably start with by talking about perfect squares, okay? Perfect squares are numbers where a number times itself multiplies to it. So I can't spell all of a sudden. So examples of perfect squares would be 1, 4, 9. 9's a perfect square because 3 times 3 is 9, okay? 4 times 4 is 16, 5 times 5 is 25, 36, 49, 64, 81. Uh, 100, 121, 144. Those are the ones up to 12 times 12, which are probably the most common that we use, okay? So sometimes it's good just to have that list and you can have it on the side of your paper while you're working on this. Anyway, so what I'm doing is I'm looking for, what are the factors of 24, and I'd like to have the biggest perfect square that I can get out of there. So, for example, 12 times 2 is good, but neither one is a perfect square. 8 times 3 is good, but neither one of those is a perfect square. 4 times 6 is good, and 4 is a perfect square. So there's a law of radicals that says I can, break up one radical into okay, so I can break up 24 into 4 times 6, and I don't always show that step, but that is a step. And from there, I can give each thing that's connected by multiplication under the radical, its own radical. And then I can take the square root of 4, which is 2, and I'll leave the square root of 6. Now, there's nothing you can't break up the square root of 6 anymore, because the only thing that multiplies to 6 is 3 times 2. You don't ever want to use the 6 times 1, the 1 times the number in this case when you're reducing radicals, because you end up right back where you started. So anyway, that's basically how you do that, where you break up radicals. Now, one other thing I should get into before I get too far here is just a couple of basic things about radicals. The square root of 3 times the square root of 3 is 3. The square root of 5 times the square root of 5 is 5. The square root of 6 times the square root of 6 is 6. The square root of banana times the square root of banana is banana. That's a horrible banana. Let me redraw that. All right, so those are some basics about square roots as well. You'll be coming up against that a lot. Believe me, it sounds stupid, but I'll go up to you and be, what's the square root of banana times square root of banana? You'll be like, banana. Oh, I get it. Now I get the answer. Anyway, so that's going to come up a lot. Number 2. Reduce the square root of 32. All right, so with this one, I'm looking for factors of 32, and I want them to be a perfect square. So 4 times 8 is good. 16 times 2 is better. You want to take the biggest perfect square, and 16 is bigger than 4. So I'm going to use that one. So I usually go straight to this point right here where I just put square root of 16 times the square root of 2. I skipped that middle step I showed you the last time. And then I take the square root of 16, which is regular 4. Not the square root of 4, regular 4. 4 square roots of 2. You can say it that way. 4 times the square root of 2 or 4 square roots of 2. Sometimes you might even hear me say 4 root 2. That also means the same thing, okay? Now, suppose, for example, I had picked this one instead. The square root of 4 and the square root of 8, which doesn't have the biggest perfect square, but we're all not perfect. You don't always get the biggest one first. Square root of 4 is regular 2, and I got 2 times the square root of 8. So then you'd want to look at the 8 and say, geez, I can break that up into 4 times 2. So you're not done yet. And then I can take the 4, which is the square root of 4 rather, which is 2. So I got 2 times the square root of 2, and 2 times 2 is 4. So notice how I got the same answer this way as I did over here with the 16 and the 2, but this way was much shorter. Okay, so that's why I said, do it that way if you can. Pick the biggest square root. All right. Number 3. Okay, so I got the square root of x squared y squared. All right, so here we go. So anything that's squared means it's times itself, right? So that would be the square root of x squared y times the square root of x squared y. And look at that, right away I came across a problem where it's the square root of banana times the square root of banana, which is banana. So what you're left with, in other words, is what's ever under the radical. X squared y, boom, you're done. And just like that, I'm moving on to the next one. Okay, now I'm going to introduce a new thing to you guys. It's called an imaginary number. And it's the variable I. Lowercase I is the imaginary number, and it represents the square root of -1, okay? There's 2 major categories of numbers. There's real numbers and there's imaginary numbers. So imaginary numbers have i's in them, and real numbers is everything else. Okay, so this is going to open up a whole new realm of numbers for you. Okay, so let's say I start with this one right here. What number am I on? 4. I get, say I got the square root of -4. Okay, so I can break this up, right? We've been talking about this, or I can break up the factors of -4, put them under their own radical. So if I took 4, you want to break up the -1 and put it in its own radical, okay? And so because the square root of -1, that's I, all right? And the square root of 4 is 2. So this is actually the answer there for that one when they ask you to simplify. And I should have written the directions that said simplify. So from now on, you can actually reduce a radical number with a negative number underneath it. Now, that's not a real solution, okay? So if they say real solutions, then we're not using the I, but if it says, just give me real or imaginary, then you definitely are, or imaginary solutions. All right, number 5, so also same directions of simplify. Suppose I had the square root of -18. So I got 2 jobs. I need to break up this 18 here. So I'm going to take the 18 and the -1. I'll get that -1 out of there. And right away I know that, the square root of -1 is I. So that's done. Now, I'm not done because we already talked about how I can reduce, square roots, and there is a perfect square that goes into 18, and that would be 9, okay? You don't want to use 6 and 3 because neither one of those is a perfect square, but 9 and 2 is good. So the square root of 9 is regular old 3. So I got 3 and the square root of 2 and the I, and they're all connected by multiplication, and that's the answer. Different books have the order different. Sometimes they put the I first in front of the square root of 2. I don't personally care. Make sure the I is not under the radical, please. That's the only thing I do ask because it's already the square root of negative 1 by itself. So anyway. Okay. Good. Next. Has to do with writing a complex number. And a complex number is one that's got, a real part and an imaginary part. So for example, they go A plus BI, and this will be the real part. And the one with the I is the imaginary part. And an example of this would be like 4 plus 3i. So proper notation is putting the regular number first, the real number first, and the imaginary part second. Okay, so you should go 2 plus 3i or 4 plus 3i, not 3i plus 4. Okay, all right. But you can treat these just like regular variables, okay? So if I have 4 minus 3i in parentheses plus negative 4 plus 3i, you can add these together, okay? If I add the 4 and the negative 4, I get 0. The negative 3i and the positive 3i, those are also 0. So that one, when they ask you to add it, you just end up with 0. In that case, number 7. So that'd be the same as like 3x plus negative 3x. Guys with me, just treat it like a variable. All right, number 8. I times the square root of 5 to the second power. Okay, so there's a law of radicals where you've got two things connected by multiplication inside a parentheses to the second power, then you have to take both things to that second power. So this is the same as I to the second power and the square root of 5 to the second power. Now, I should have written this up top here, but let me write it here. I squared, and I can show you why, is negative 1, okay? And the reason is because if I took the square root of negative 1 and squared it, that's negative 1 also, okay? So let me circle that. That's an important one. Put a star next to it. Know it. Memorize it. Okay. Square root of 5 squared is the same as square root of 5 times the square root of 5, right? Which is regular old 5. So I got 5 times negative 1, which is negative 5. And that's how you do that problem. 8. Five minus 3i minus negative 2 plus 4i. All right, so this is a subtraction problem. It's got parentheses, which means, you're really subtracting everything in there. So what I'm going to do is I'm going to change all the signs in the parentheses and make this an addition problem. Okay, so I'll go make the negative 2 positive 2 and make the 4i subtracting 4i. Okay, and make it a plus. I like to do it that way. I make less mistakes. Now I can combine like terms. 5 and 2 is 7. Negative 3i and negative 4i is negative 7i. And that is the answer. Next one, number 9. Why don't you try this one? 7 minus 2i minus negative 3 plus I. Okay, you can try that one, do it out, bring it into class. I'm just going to move on to number 10. So I can also multiply with this, with imaginary numbers. If I had 3i and negative 5 plus 2i, so this is like distributive property. So if I take the 3i and I multiply it by both of these things, I will get my answer. Maybe a little simplifying. 3 times negative 5 is negative 15i. And keep the plus sign. 2 times 3 is 6. I times I is I squared. Now, I just showed you that I squared is really negative 1. So I'm going to have to, anytime you see I squared, you should change that to a negative 1 and simplify before you give your final answer. Okay, so I got negative 15i, and 6 times negative 1 is negative 6. All right, so I'm going to put this in proper form where I put the negative 6 first and then minus 15i, okay? It's good practice to do that. All right, next one. Let me write that down. There should be no I squareds in your final answers. Great. 11. Excuse me. 4 plus 3i times negative 1 minus 2i. Okay, so two binomials multiplied together. This is FOIL or box technique, whichever you prefer, okay? If I do it by FOIL, I get 4 times negative 1, which is negative 4. Outside is 4 times negative 2i, which is negative 8i. Inside is 3 times negative 1, which is negative 3i times negative 1, which is negative 3i. And the last will be the 3i and the negative 2i. Positive times negative is negative. 2 times 3 is 6. I times I is I squared. Okay, so I'm off to a good start. Let me now combine like terms. Those two go together. Negative 8 and negative 3 is negative 11i. Negative 1 minus 6i squared is really negative 1, which means I get plus 6 there. So that's really plus 6. Which means I can go 6 plus negative 1 is 5 minus 11i. What did I do? Oh, I'm a dummy. Okay, that shouldn't be 1. 4 times 1 is 4. Change that. Just wondering what happened there. Which means when I add 6 plus negative 4, you get 2. Okay, sorry about the mistake. All right, so that's the correct answer. All right, next, why don't you try this one too? You try number 12. Two minus 3i times 4 plus 5i. I talked about the box, but I didn't actually go into it. This is really the same thing as FOIL, except it's this nice way of setting it up, where I can go, 4 times and 5i times 2 and negative 3i. It's like a Punnett square, where you multiply to find out what's in the boxes and then add up the boxes. So I can go 8, 4 times negative 3i is negative 12i, 2 times 5i is 10i, 5i times negative 3i is negative 15i squared, okay? And then you'd add up all the boxes and get your answer, combine like terms. But this is a nice technique. Lots of students, I teach to my Algebra 1 kids, lots of them like it better than FOIL. It's really the same thing though, like I said. All right, so anyway, if you do that one out correctly, you should get 23 minus 2i. Next, dividing. Nine plus 12i over 3i. All right, so that's considered a radical in the basement, and you're not supposed to have any radicals in the denominator when you give your final answer. So what I'm going to do with this one is the way to get rid of it is if I have I times I, that's I squared, which is really -1. So that will be how I get rid of the square root of -1 in the bottom of the fraction. So when I do this, I get I times 9 plus 12i over 3i squared. Okay. And then I can do distributive property with the I in the numerator. 9i plus 12i times I is 12i squared over 3 times I squared, which is -1. Okay. Once again, I squared is -1. So 12 times -1 is -12 plus 9i. And 3 times -1 is -3. Often they don't really like having negative numbers in the denominator. Okay, so I think I got kicked out of my system for a minute there, so let me zoom out for a second so I can show you where I'm at. So I multiplied top and bottom by I, and then I did distributive property with the I and the 9 plus 12i, multiplied it out, got 9i plus 12i squared over 3 times -1. Now, like, I don't have too many issues with this, but I know if you're looking at the answers in the back of the book, that having that negative number in the bottom, they usually don't do it that way. What they'll do is they take the numerator and they'll pull out a negative, which will give me positive 12 minus 9i, and then the negatives and the two negatives, one in the numerator, one in the denominator, cancel out, which gives me 12 minus 9i over 3, okay? Those two negatives cancel out. So this is the answer you'd see in the book, all right? Okay, so that's number 13. Oh, one more thing. I'm actually not done with this one because this is something we can do. I can reduce that, okay? If I go over here to these numbers, both 12, 9, and 3 are all divisible by 3, which gives me 4 minus 3i, and that is the best answer, okay? I could have factored out, let me do this in a different color. If I took that numerator, both 12 and 9 are divisible by 3, which would leave me with 4 minus 3i, and I'd be left over 3 here. So those 3's cancel, and I'm left with a 4 over 3i, okay? All right, anyway. 14. 2 plus 3i over 1 minus 4i. All right, now when you get rid of the radical in the bottom and you have addition or subtraction, the only way that I've figured out, and I didn't figure it out, but the only way I've seen to do it is make a difference of 2 squares out of the denominator. So whatever's here, do the same thing, but make it the opposite sign in the middle. So in this case, I got 1 minus, I want to have 1 plus 4i. And you can't just multiply the bottom by that. You have to do top and bottom by that. So I'm going to multiply top and bottom by 1 plus 4i. And when I do that, I'm going to have two sets of parentheses, 2 plus 3i times 1 plus 4i. over, now when I do difference of two squares, that's you square the front number, 1 squared, keep the subtraction sign, and then square the back number, which would be 4 squared and I squared. All right, so I'll start there and we'll start simplifying this. There's more to do here. Okay, next. So I'm going to FOIL out the top. 2 times 1 is 2. Outside is 4i times 2, which is 8i. Inside is 3i times 1, which is 3i. Last is 3i times 4i, which is 12i squared. Okay, 1 squared is 1. I squared is negative 1. So 4 squared is 16. It becomes plus 16. Okay, moving right along. I got 8i plus 3i is 11i. I squared is negative 1, so that's minus 12. 12 times negative 1 over 17, all right? And one more thing I can do here is add the 2 and the negative 12 together, and I get negative 10 plus 11i over 17. Not the only way you could write the answer. That is the answer, by the way. You could also write it as negative 10 over 17 plus 11/17 I. Same thing, okay? Just written differently. All right. We'll make the last one a U try, which is number 15. Once you try this one where you go 4 minus I over 6i. And I want you to reduce it, okay? So there's no addition. You don't have to do a difference of 2 squares here. You can show me what you get. Bring it into class. The answer should be negative 1 minus 4i over 6 if you have the positive version, or the denominator being positive, okay? So that's the answer. Show me how you got there. Very good. With that, I'm going to close things out with a little more music. Have a great night.
Top coat, top hat, I'm